Using data from NASA's James Webb Space Telescope, scientists identified an unusual cosmic object with a striking infinity symbol shape, formed by two compact red nuclei, each encircled by a ring. This peculiar structure is believed to be the result of a head-on collision between two disk galaxies. But the real surprise lay in what they found at its heart: an active supermassive black hole nestled between the two nuclei, embedded within a vast cloud of gas. The presence of a supermassive black hole in this location challenges conventional theories about how such cosmic giants form. Typically, supermassive black holes reside at the centers of galaxies, not in the space between them. The team proposes that this black hole may have formed directly from the collapse of a gas cloud, a process known as the heavy seed theory, which could explain how some of the earliest and most massive black holes in the universe came into existence. The mystery of supermassive black hole formation has long puzzled astronomers. Two leading theories attempt to explain their origins. The light seed theory suggests they grow from smaller black holes formed by collapsing stars, which then merge over time. However, this process is slow, and recent Webb observations have uncovered supermassive black holes in the early universe that may have formed too quickly for this scenario. The alternative heavy seed theory posits that massive gas clouds could collapse directly into black holes, bypassing the star formation stage entirely. Yet, this process is difficult to achieve, as gas clouds tend to fragment into stars rather than collapsing into a single black hole. The infinity galaxy may provide the missing link. The researchers hypothesize that when the two galaxies collided, their gas was shock compressed, creating a dense knot that collapsed into a black hole. Supporting this idea, observations reveal a large expanse of ionized gas hydrogen, stripped of its electrons centered around the black hole. To rule out alternative explanations, astronomers considered whether the black hole could be a runaway object ejected from a galaxy, or the central black hole of a third unseen galaxy. However, follow-up observations with Webb revealed that the black hole's velocity closely matches that of the surrounding gas, making these scenarios unlikely. Instead, the evidence points toward a black hole born from the gas itself. Adding to the intrigue, the team discovered that both galactic nuclei also host active supermassive black holes, meaning the system contains 3 such objects in total. This rare configuration offers a unique laboratory for studying black hole formation and galaxy collisions. While the findings don't yet provide definitive proof of direct collapse, they offer compelling evidence that such a process could occur. The discovery of the infinity galaxy and its central black hole marks a significant step toward unraveling one of the universe's greatest mysteries: how supermassive black holes come to be. As researchers continue to analyze the data, this cosmic oddity may hold the key to understanding the origins of the universe's most enigmatic objects.